Optimization with calculus. We have a box with a square base and no top made from 108 square inches of material. The base side is x and the height is h. Find the dimensions that maximize the volume. Build a quick visual of the net. One square base accounts for x squared. For rectangular sides, each contribute x times h. Let's mark x along the base and h along a side. The surface area with no top is base plus 4 sides equals 108. So, a equals x squared plus 4xh equals 108. Solve the constraint for h. 4xh equals 108 minus x squared. So h equals 108 minus x squared over 4x. This single formula ties height to x and will let us write volume as a function of x only. Volume equals base area times height. V equals x squared times h. Substitute h from the constraint. Simplify to v of x equals 1/4 times 108x minus x cubed. Differentiate to find the peak. V prime of x equals 1/4 times 108 minus 3x squared. Set v prime to 0 for critical points. That gives 3x squared equals 108, so x squared equals 36, and x equals 6, the positive solution. The second derivative is negative at x equals 6, so this critical point is a maximum. Now find the height from the constraint. H equals 108 minus 6 squared over 4 times 6, which is 72 over 24. So h equals 3 inches. The maximum volume is x squared h equals 6 squared times 3 equals 108 cubic inches. Quick visual cue. The purple curve is the volume as a function of x. The peak at x equals 6 is the maximum. For steps, set up the area constraint, express h, write v of x, take the derivative, and solve v prime equals 0. Final dimensions, base side 6 inches, height 3 inches.
Thank you for watching. Tap like, share, and comment, and then follow and subscribe for more quick problem-solving tips. Let's make maths simple. One video at a time only on Myverse Maths.